Greetings my dear viewers and welcome to our studio presentation. I am Neda Shakil, pursuing Masters in Construction Engineering and Management at CPEMC University, Ahmedabad. As a part of Studio 2 Construction Project Execution Monitoring and Control, under the guidance of Dr. Ganesh Devkar and Dr. Jyoti Trivedi, we have undertaken a live institutional residence project where we focus on the execution phase of a project life cycle. This group activity entailed regular site visits to understand and analyze the data from perspective of different concept, tools and techniques. Portfolio briefly demonstrate few processes undertaken as a part of study, namely introduction, site layout visualization, planning and scheduling, quality management, safety management, lean construction, green building rating system, and finally listing the key learning from the exercise. The objective of the project is to provide soothing and comfortable housing community for the staff and faculty members within the campus. The overall project cost is 110.45 crores. It's a lump sum type of a contract. It started in June 2019 and will be completed by September 2023. The site is located in Vastrapur, Ahmedabad and is highlighted on the map. It is divided into old and new campus. It consists of 3 main entrances and 3 secondary entrances highlighted by arrows. Also, it consists of a labor colony behind Alpha 1 Mall at a distance of 1.5 km. The selected project is situated at southwest corner of the old campus, where the staff housing will be G+10 structure and faculty housing will be basement plus 14 floor structure. On the left, we can see 3D model of the site, which showcases the status as on 7th February 2022. Where the staff housing Tower 1 and Tower 2 both were built up to 3 floors and the faculty housing Tower A was built up to 2 floors and the Tower B was at foundation stage. Site layout visualization. Visualization is a process of converting data into graphical representation. So here we have used Revit software to understand current circumstances on the construction site. On the right in the 3D model, I have highlighted the components of the staff and faculty housing such as barricades, vehicular movement, security cabin, entrance gates, toilet, offices, tower crane, steel yard, CCTV. This helped us to understand the movements and activity area at site to take effective decisions for minimizing the risk and have easy communication. With the help of Revit software, we can derive area and material takeoff schedule depicted in the table, which would provide a hint regarding the quantity and cost of the material beforehand. Also, path of travel analysis was used to calculate distance and time for different paths as highlighted by the red, blue, pink, yellow dotted line. With the help of this, we can reduce distance and time by proposing relocation of toilet and office. Planning and scheduling. One of the most important aspects of project planning is project scheduling and tracking. For our project, it is done using Primavera P6 software. After creating enterprise project structure and new project, we add organization breakdown structure and work breakdown structure. Then we define project calendar where we add working and non-working date and time along with exception dates like holidays. Under the work breakdown structure, we assign activities where we add activities name, start, finish date, duration and predecessor. And with the help of the filter tab, we can achieve milestone and 4-week look ahead schedules. Next comes the concrete planning. Concreting is calculated for column, shear wall, slab, beam, staircase, and here the faculty housing tower A and B are identical. So first we calculated one floor concrete quantity for each tower by multiplying pour areas highlighted in plans with height or depth achieved from the drawings. The calculation is depicted in the left table. Then we calculated coefficient of concrete by dividing total volume of concrete with total built up area. This is useful to know volume of concrete required for 1 square meter. Beforehand planning of material and equipments can be done with this. For the labor productivity, 35 to 40 labors were noted for concreting at site and time 8.5 hours for 150 cubic meter. With these assumptions, productivity was calculated, which is beneficial for analyzing labor requirement to increase or decrease without affecting the work progress. Next, we attained the monthly pour requirement for all 4 towers, where we observe maximum 7 pours in the month of January. For next 8 months, it was constant 5 pours per month from February to September, and in the last 4 months, only 1 pour per month is required. The concrete is transported from in-house batching plant situated at new campus at a distance of approx 1 km. The efficiency of batching plant is 80% and actual actual capacity is 30 cubic meter per hour. The transit mixture of 6 cubic meter takes 12 minutes to fill and it can fill 4 TMs in 1 hour. The to and fro motion of TM from plant to the site takes 36 minutes and its bifurcation is indicated in the flow chart. 3 TMs are required to run plants and pump with efficiency. Since site is operable for 8 hours, therefore 78 cubic meter of concrete can be attained by 1 TM per day. With this, we calculated number of TMs required for each tower, where we observe 2 TMs are sufficient, but for staff housing tower 1, 3 TM are required and site only provide 2 TMs, so this may be one of the reasons for delay in activity. For the quality management, one technique is linear responsibility chart, in short LRC. It is a visual depiction of the authority interrelationships between stakeholders. It reveals who participates to what extent. For this, first we understood the quality organization structure, then their roles and responsibility, and prepared LRC. For the preparation of LRC, we add job titles on top row and activities related to quality down the side of chart. Here we use chess symbols highlighted with colors to indicate level of authority, such as actual responsibility, general supervision, must be consulted, may be consulted, must be notified, highlighted in the legend. For example, preparation of the QA/QC plan. It is the responsibility of quality manager under the supervision of quality in charge engineer and must be consulted with the chief manager from client side. At the end, we did plus and delta analysis, and few of them are: in the plus, we have weekly meeting and daily reporting are done with project management consultant for quality. The work distribution among client side is clearly defined and organized. In the delta, we have resident engineer involvement is required for the better quality output. Senior engineer should participate more for approval and reviewing process. Involvement of architect in preparation of quality assurance plans should be ensured. Safety management plan. At a site, environment, health and safety, that is EHS plan, is implemented. We have compared the EHS plan with contract document and OSHA guidelines, and few areas of improvements are listed here, such as penalty for housekeeping, tire washing facilities should be present. As per OSHA, who report hazard would get incentive, but at our site, it is not followed. Hence, we propose safety incentives. Awards can be given in the 3 bases. First is the outcome based. If the activity is performed injury free, they are awarded. Second is the behavior based, who exhibits certain safe behaviors and actions. Third is the activity based, who participates in external safety programs are awarded. The awards can be in the form of there and then award like breakfast coupon, or monthly awards like safest staff of the month or safest worker of the month. On the right side, the components of the EHS are mentioned and few of them are discussed here. The first is EHS induction training. It is mandatory for 1 hour training session. Attendance report is maintained, and it was concluded that at our site the room for 15 persons are available, but the contract says that it should be for at least 30 to 50 persons. Till date, total of 900 workers have undergone this training. Next is the toolbox talk. It is held once in a week, but we suggest that it should held every day for an hour, and during the weekend it can be more elaborated version. Till date, 10,061 persons have undergone this. Next is the EHS committee. It is a monthly basis meeting, and the committee consists of a chief executive, chairman, secretary, members from the workers and staff. The inferences out of this was that before meeting agenda is released and area of concerns are discussed in the meeting. In the next meeting, those discussions are reviewed and closed. Next is the penalty for non-compliance. If there is any penalty, they have to give an apology letter, and they are maximum 3 warnings before termination. And if there is a non-compliance of PP, they have to pay rupees 500. It is not mentioned in the EHS plan, but it is followed at a site. Till date, 67 apology letters and 4 employee warning memo have been collected. Total of rupees 8,000 for penalty has also been collected. Under lean construction, Foreman Delay Survey is one of the lean tools for measuring performance and improving productivity. For this, we took shuttering activity of ground floor slab beam and observed 2 carpenters and 2 helpers. The process for the Foreman Delay Survey is indicated in the flowchart at the right side. The delay observation is done under 13 categories. Here in delay comparison between carpenters and helpers, waiting for fellow crew members was major delay reason, followed by prefabrication error and waiting for information. Next, we observed as per the pie chart that major delay is caused by helper 1, that is 36%, and the least delay is caused by the carpenter 1, 17%. Then we did cost analysis. We observed carpenter 1 and helper 2 were more efficient as compared to others, and total lost cost is Rs 515 per day. We also provide suggestions to reduce delay, such as use of toolbox, schedule breaks, storing materials nearby, adequate planning of activities, and providing space for every crew. Green Building Rating System. At present, our project does not comply with any green building rating system, so we opted IGBC checklist. In the left graph, under 8 categories, possible points are indicated. As per present situation, it scored 23 points, and after providing the suggestions for each category, it can achieve 57 points, which makes the project's silver certification level. Then we analyzed IGBC guidelines combating COVID-19, where for the 4 categories, green states number of subcategory followed at a site and red states not followed at a site. In conclusion, the project currently takes very few precautions in the terms of material handling. Any material brought in from outside be stored separately and used within 48 hours. At last, we also analyzed CPWD rating system, where in 9 categories after proposed system, it can achieve 59 out of 100, which can be certified as green. In conclusion, the studio provided us hands-on experience of a construction project for various aspects such as safety, quality, scheduling, material management, and more. The discussions with the site personnel and expert lecture enriched the studio experience. The key learnings from various deliverables are as follows. Site layout visualization. The use of BIM software helped us to understand interconnection of activities and components of site. It was also useful for the material takeoff sheets and path of travel analysis. Planning and scheduling. Primavera P6 software was used for planning and scheduling, and we tracked 4-week look-ahead plan. In pour planning concreting, the peak requirement of concrete and labor productivity was calculated. It was also concluded that minimum 3 TMs will be required for the batching plant for its efficiency. Linear responsibility chart. Preparing the chart helps us to understand the gap among stakeholders. It was concluded that the project engineer communicates with project manager and engineer in charge for quality control. Safety management plan. We understood the contractual requirement for this and compared it with OSHA guidelines. We also understood the components of AHS plan. At present, there is no safety incentives, so we have proposed the same. Foreman Delay Survey. The most common cause of delay was waiting for fellow crew members, followed by prefabrication work. Much of the non-value adding time could be eliminated by improving the project management, and more emphasis on work planning and preparation must be done. The total loss cost was Rs 515 per day. Green Building Rating System. After suggestions, the project can achieve IGBC Silver certification level. We observed more points were in the following categories: site selection and planning, water conservation, energy efficiency. Also, CPWD rating system with proposal can achieve green certification. Thank you.